So statistics. So statistics in the earlier discussion, it is more like approach, more like discipline, more like methodology, something like that. But I'm going to redefine the term. So among statisticians, statistic is nothing but a function. So statistics, if you call this as a study, one of the academia discipline, then it's going to be a field or area of study. So what we defined in the previous discussion was correct. But where we are going to look at statistics as a technique, and as a technique, where statistic is nothing but a function. So this function T is taking some input and making some output. And the input is data. And based on the data, you're going to get some number out of it. So where average was a statistic. So average M, you have given set of data and taking the mean of it or taking the summation over the number of instances. So this is essentially a function, and average in this context a clear example, a concrete example of statistic. But speaking of average though, there are two possible options. So one is sample mean. So you have a sample, n different sample, right? This should be n, capital N. So you have n different sample, taking the sum and divided by n, then you can come up with the mean value. We often use this notation mu to represent the average. But let's think in different way. So you have, well, we have discussed sample space and probability. So let's use it. So you have sample space of all possible value from x1 to xn. So these are all possible values in my sample space. And each of them has associated probability. So if you take the multiplication between probability of a probability value and actual observation, and taking the sum, and it's going to be my average. And from the statistical point of view, we call this as expectation. So here comes an example. You have 5 fresh students. So their ages are 2019, 20, 21, 19. And taking the average, what we did normally is taking the sum of all of those ages and divide them by 5. Then you can come up with 19.5, 19.8. And expected value, where you looked at the statistics and you have student, 20% of the student age 19, 50% of the student age 20, and 30% of the student age 21. So you associate those probability value with actual age value. And taking the sum simply, then you can come up with expectation. So expectation and sample mean, both of them are valid average value. I was trying to explain the variance in the same notion, and here we have population variance and sample variance, where population variance dividing the quantity with n, sample variance dividing conceptually same quantity with n-1. So there is this is something called as unbiased estimator, where there will be a homework problem related to this. So we'll just give you a heads up. And why we have two different notions for this is actually one is from population statistics, the other is from sample statistics. So population is the world. So where we have world of students, out of them, this is my small sample. So oftentimes this sample is much smaller value. Let us do the actual study and computation. So sample is a smaller group of members, but the big condition is this sample should come from the population. So sample is the representative my population. And sample selection must be random and where the population individual should have equal opportunity to be selected. Well, that's what this slide basically say. The most important thing is this diagram. So you have the world of student. Out of them, you have your own sample. And from there, you have sample mean. But this sample mean is to estimate this population mean. So, well, I'm trying to be strict. That's why I'm trying to distinguish between where this is the population mean and sample mean. And what we intended is more important. So sometimes we do probability value. So, well, statistical value. So one is from population, more like idea. So something we cannot achieve at all. And maybe the true value of this mu, where we probably cannot know. But where from sample, where we can estimate it, where that's what those statisticians are doing. So from the sample, you want to go to the idea, and that process is called as inference.